Hello everyone! Welcome to our video tutorial. My name is Criza Mascardo
Carlo Corvo,
and we are here to explain
Cosets,
and Laranges theory. To fully understand the group G, you need to take a subgroups part and study the pieces. These pieces are called subgroups. To begin in finding subgroups, we are now using cosets, and the result is Laranges theorem. And now, we will show you and prove how it can be. Okay, now, subgroup. Subgroup is equal to subset and group. H is a subgroup of G, and now it is how we write. H is less than to G or group. G group or a subgroup has a two standard subgroup of G. This is the group or itself and the trivial group, which is an element.
mathematician Joseph Louis Larange, he discovered Larange theorem. It said that subgroup can't be any odd sign. Larange theorem, if H is less than equal to G, then the order of H divided the order of G. The order of G is equal to number of elements of in G equals to Larange theorem. If H is less than equal to G, then the order of H is divided the order of G. Order of G is equal to number of elements of G is equal to absolute value of G. Larange theorem proved that H is less than equal to G implies absolute value of H divides of absolute value of G.
Before proving this theorem, let's see how this is being used or how is this useful. Now, Laranges theorem. Let G be a group with absolute value of G is equal to 323. That is 17 times 19. The divisor of 323 is or are 1, 17, 19, and itself 323. Possible subgroups of orders are 1, 17, 19, and itself 323. Now, the standard subgroups of G and absolute value of E. Then the absolute value of G is equals to 323. And then we have now the absolute value of E is equal to 1. Any other subgroup has order 17 or 19.
And now we need to learn the notation of Larange theorem. Since the absolute value of G is equal to 323 and 17 times 19. So the question now, does Larange theorem say here are subgroups of order 17 and 19? The answer is no. If H is less than equal to G, then absolute value of H divided the absolute value of G.
And now we have an example, A4 or alternating group on 4. And now we have the elements and then the number of subgroup. So the ordered number R or the orders are absolute value of A4 is equal to 12. Why? Because we have the divisors 1, 2, 3, 4, 6, and 12. And now the subgroups are order 1 is equals to 1, order 2 is equals to 3, order 3 is equals to 4, order 4 is equals to 1, and then the order of 6 is equals to 0, and then the order 12 is equals to 1.
Larange theorem. If H is less than equal to G, then absolute value of H is divided to absolute value of G. They have a proof. G is a finite group with absolute value of G equals to N. They have a case number 3. H is less than G and H is not equal to all elements construction. Pick G1 all elements of G not in H, and G1H equals to all elements G1 times H for all H is elements of capital H. Then this is called left coset. So H and G1H do not overlap. There are examples. H is union G1 and H equals to null empty set.
And now, H and G1 of H have no element in common. So let's assume that there is an element in H and G1 of H. This means that G1 times Hj is equals to Hj for sum H1 and Hj in H is equals to J1 times H1 is equals to Hj. And now, J1 times H1 is equal times H1 or inverse is equals to Hj times H1 inverse. J1 times Hj times H1 inverse is equals to Hj times H1 inverse. And J1 times E is equals to Hj times Hj inverse. J1 is equals to Hj minus H1 inverse is an element of H in which implies to J1 and an element of H. And now the contradiction is J1 is an element of H. So the assumption there is wrong and it implies that it is true.
Now let's go back. Laranges theorem. If H is less than equal to G, then absolute value of S divided absolute value of G. Proof that G is a finite group with absolute value of G equals to N. Case number 3. So H is less than G and H is not equal to all elements. So they have construction. Pick G2 is all element of G is not in H or G1H. So G2H equal to G2 times H where all H is element of H. H and G2H do not overlap or G1H and G2H do not overlap. So they have a table. E is equal to H, then G1 is equal to G1H and G2 is equal to G2H. So, ta-da!
And we are finished.
Yes.
We're done. Those what we have shown you is just an example only. But there's still a lot of examples and proofs, proofs of how Laranges and Cosets
It works together.
how useful.
Yes.
And we hope
Understand
you understand
my
our explanation. And hope